So you should have just watched the video from Dirty Jobs that showed the actual inspection or cleaning of a actual septic tank. And you'll notice in that video, they also are pumping it down, and they use the mirror to kind of check the tank for cracks and all of that. So if you watched the video, you saw that there were 2 inspection ports that could be used. These are also popped off and are used for putting that suction hose down for pumping them out. And this one you can actually see a baffle in there. So these baffles are important for, again, keeping the scum trapped in the middle. There's another component on the outlet baffle that I'm going to show you a picture of here called the Zoller filter. So I'll pause this and pull up that picture. So here's just an example of an effluent or Zoller filter. So you can imagine that this is going to go out to the soil distribution system. And there's fats, oils, and greases back in here. And then down here is where the water can make it into this. And it'll come up and rise out, and it'll stay at a level inside this tube up here. But that water, in order to get into that tube, would have had to come in here at a lower level. So it's high enough off the bottom that it's not collecting sludge. If your sludge gets so high that it clogs this up, that's going to be a problem. If the sludge gets so high that it continues to jam up through here and go out into the distribution system, that's a problem. One way to prevent the system from getting clogged up and from anything potentially making its way through here is to have an actual Zoller filter. Now again, hopefully the fats, oils, and greases are trapped back here, and the sludge is all trapped on the bottom, and only the liquid is going into here and leaving the septic tank as effluent here. You can pull these things up and out and clean them out. Then they look like this, and they just kind of drop into that sleeve, and you can pull them out, and they're graded. They allow the water to get through, but the big stuff will get caught in them. And if too much stuff gets caught in there, then you will notice your septic tank will end up potentially overflowing at the top. So just good to know. We use them to prevent anything from going out into the soil distribution system that you wouldn't want out there. So these septic tanks are watertight containers, and they have, again, usually 1 or 2 compartments, and some places will put 2 or 3 of them or string them together as needed if they need more septic tank space. Again, the most important component of the septic tank are these baffles. The inlet baffle forces the wastewater down, preventing the short circuiting of the fats, oils, and greases in particular, and that scum across the top. The outlet baffle keeps that scum layer from moving out into our soil absorption system. So the septic tanks, as you saw in that video, they have an inspection port. They actually have 2 usually. And those inspection ports are used for checking the condition of the baffles, cleaning out that filter, also for pumping out the tank. There are different sizes. The 750-gallon tanks I don't think are permitted anymore in Kentucky. I think the minimum size is like 1,000 gallons. And these are the size tanks for 1 or 2 bedroom homes. If a home has more than 1 or 2 bedrooms, if it's a larger home, they may be required to have a larger septic tank. And if they can't find a larger septic tank, there are accommodations that can be made where they can string several tanks together. It's better to have a larger tank than what you may need. You may have people living in a home that has 6 or more bedrooms where maybe the only 1 or 2 people live, and that tank may not need to be maintained or pumped out as frequently. So the septic tanks function by the sludge settling out, the scum staying on the top and staying trapped in the system until it's cleaned out. The effluent goes to a distribution box where it then may go into a series of one of these leach lines or these soil distribution lines. This is all called the soil absorption system or the soil leach field. These also have to be set back from property boundaries, wells, drinking water lines, lakes, rivers, ponds, that kind of stuff. And it's recommended that a replacement area after maybe 30 years or so, or a period of time, if you had to replace this, that you have an area prepared to be used. The soil absorption system ideally has 4 feet of high quality soil underneath of it. Why 4 feet? Well, in the first 3 feet, the bacteria are typically consumed by the soil microbes and degraded or become inactive. Or between 3 and 4 feet, almost all the viruses are inactivated. Viruses travel further. There's some research that says they can travel even further than that, but ideally 4 feet will allow for the effective removal of the viruses. The bacteria and parasites are removed in the first few feet. 4 feet is what's needed to remove the viruses. These lines are kept under the ground, and you can see here 6 to 18 inches of soil above it. There's some fabric that that protects this, and if they're digging, you hit fabric or gravel, you know you're going to get too close to the line. This pipe is perforated, so again, that's why we keep the sludge and the grease and stuff out of these, because those perforations, those little pinholes, they're a little larger than a pinhole. Those little holes can get clogged up very easily. And things like gravel around this help protect the pipe so that if it was to have pressure over the top of it, it's not going to crush or compact soil around the pipe and cause these little pore spaces to get clogged up from the dirt from the outside. The gravel prevents dirt from clogging up the little pore holes. The soil absorption system, again, ideally has 4 feet of permeable soil. When we look at the Kentucky standards, you'll see that people can get away with less than 4 feet of soil. And that's just the nature of the state that we live in. Kentucky doesn't always have 4 feet of soil in a lot of the areas. But, there are areas that do meet that. So if you had a 3-bedroom home and a percolation rate of about 3 minutes per inch of soil, you may need to dedicate this much space of your yard, 4,400 square feet. So you're looking at, 200 feet, by, 20 feet or so. So you're looking at dedicating some serious area. If the percolation rate for that same size home is really slow, like 60 minutes per inch, you're looking at having to have a 9,000 foot area. So here's an example, 95 feet by 95 feet in your backyard. So it can be a lot of area. These areas can't have like cars and stuff parked on top of them or trees planted. You need to leave the areas alone. If somebody does not have enough suitable feet of soil, say if they don't even have enough in Kentucky for our lower limit, say that they don't have 30 inches of soil or 36 inches of soil, what might they do? So we can look at trucking soil in, but in general, we need 4 feet of soil so that the bacteria are used up and the viruses are also not just used up. The bacteria are filtered out, consumed by microbes in the soil. We need 4 feet of soil because that helps remove all the viruses, or at least a sufficient number of the viruses. If we don't have enough soil, we can increase the soil depth by bringing in soil. So you can have a mound system installed. So here's an example of the cost of a septic tank with a sand filter and irrigation rather than the soil system. So you got a septic tank, and then the effluent goes out to a sand filter like you saw in those wastewater treatment plants. Those are more expensive, $250 a year, because you're going to have to get rid of that sludge or whatever accumulates out there on top of that sand. The septic or mound system, where you have to essentially build up, instead of being at the ground level, you have to add soil up several feet. That means you're going to have waste leaving the house, probably underground, and then it's going to get to that, and you're going to have energy costs to pump the waste up into that mound, and then it'll travel down. That energy costs money. So you're looking at $150 a year. About $100 of that per year was an energy cost. then there's this $50 a year cost that says that, hey, every few years you might have to spend, and that's part of the United States, $250 or so, or maybe up to $500 to have the sludge every 5 years or so pumped down. You still have a septic tank. That one still has a septic tank. If you have a soil absorption system, you only have to spend about $50 a year once you've installed the thing, and that's $50 a year times 5 years. So you're looking at $250 once every 5 year cost to pump the thing down. It's important that in that soil distribution system or that absorption field, we don't have heavy equipment, even cars and stuff parking on top of it. Soil compaction will make that system not work very long. We also don't want a lot of water standing out on top of it. Surface water or rainy water increases the amount of water that's in the soil, and that can make it harder for the microbes to process all of the good stuff that we want to get out of there. It makes it more anaerobic, and the system just doesn't work as well. So reducing the amount of water going into the septic tank and soil distribution system will prolong its life. Also, not dumping a lot of stuff down the toilet, fats, oils, and greases. Even like reducing the amount of toilet paper and stuff that might produce sludge in the septic tip system can actually prolong the life of the septic tank. And then having it pumped regularly, like once every 5 years for a normal house. If the house is only rated for a septic tank for like 5 people, but like 12 people are living there, then that septic tank is going to need to be pumped more often. If the septic tank is on a house where maybe somebody's running one of these home kitchens and doing a lot of baked goods and there's a lot of grease going down the drain and they're running like a commercial kitchen out of a house, it's also going to need to be pumped more frequently because that grease will accumulate more and there'll just be more sludge being generated. We don't want chemicals going down our toilets that are going to be harmful to the septic system, or excessive amounts of bleach if the washer and dryer, or if the wash machine, is hooked up to the septic system. A lot of chemicals going down the drain harm the microbes that are in the septic tank and really harm the microbes that are out in the soil distribution system. So we don't want them to die. We want them to be healthy and doing a good job breaking down all of that waste. And you can speed up the breakdown of the waste in the septic system as well in like a mound system by actually adding aeration. So that's another alternative step to make your system function better. And aeration is sometimes included when they don't have enough soil. They will sometimes use aeration in those mound systems as well to just help make it easier for stuff to break down. Septic inspectors are going to do dye tests, and I've got a video online for you if you want to see what the dye looks like. They sometimes come as like little red tablets called fluorescein dye tablets, and you can drop them in a distribution box and then see if it ends up on the surface. And if it ends up on the surface, then you know that that water is coming from that septic tank. You can also, with the homeowner's consent or work with the homeowner, drop them down the pipe or down the toilet in the house and then come back in a couple days and see if you see any dye standing on the surface or in any of the nearby creeks. You would also notice unusual smells or odors. If you walk through the yard, it might be muddy. The smells and odors, you might smell this weird smell of like a mixture of like sewage and laundry detergent. You might see soap suds. They come up on the surface. And then there are dogs that can sniff sewage. So sometimes people who have failing systems have been told by the health department, your system is failing and you need to fix it. And instead of fixing it properly, they pay somebody they met off of Craigslist or some yard sale site on Facebook who says he'll fix it for $500, and he runs a trench to a creek or trenches to a stormwater pipe and illegally, essentially straight pipes your septic tank into a stormwater system, which is illegal. But homeowners would plead ignorance. Oh, I didn't know. I paid the guy $500. I thought he'd do a good job. So there are dogs that some communities in the United States have employed to track down these illegal connections of wastewater effluent from septic tanks into stormwater tanks. Now, septic tanks are the best that we've got for homeowners, and we can probably do better. This paper was published in Environmental Science Technology after a couple years, I believe, of being embargoed at EPA before they finally got the peer review to go through to allow this to get fully published. And I think it was just kind of the agency was wanting to make sure it was really, really right before they did it, because there were maybe some concerns that what are you going to do if your wastewater systems aren't working at your homes? So here in this picture, it shows the log 10 septic density per square kilometer. And this is 10 to the second power. So 10 times 10, 10 to the second power is 100. 10 to the 1 power is 10. So here's 100 septic tanks per square kilometer. Here is 10 septic tanks per square kilometer, and this is about 1 septic tank per square kilometer. And here is the amount of human-specific fecal bacteria that they measured in the water using this human bacteria gene. There's a bacteria called Bacteroides, and there are certain ones that live in the gut that have a gene that they know it's Bacteroides, particularly Bacteroides fragilis. There's a few other ones. So they have this human fecal marker here. And when they find that human fecal marker in dry weather, you see here's how high it is in dry weather and in wet weather. So it didn't matter if it rained a lot or not, wasn't a whole lot of difference. And here, again, when you don't have a lot of septic tanks, was not a whole lot of difference between the wet weather, so when it's raining, and the dry weather events for the amount of fecal bacteria. But as you start getting to more than 10 homes per kilometer squared, per square kilometer, you start to see here are the dry weather levels of bacteria from humans. And then when it rains, here are the wet weather human fecal markers. And you can see there's a lot more of them. So septic tanks probably do a pretty good job during dry weather, but as the population density increases of homeowners with septic tanks and it rains heavy, that's when septic tanks fail and that soil distribution system just can't treat the wastewater and ends up bubbling up to the surface and running into our nation's rivers and streams and lakes. And you can see a very strong correlation between, it's a 1.0 is perfect correlation, and you can see here a strong positive correlation between the amount of septic tanks and the amount of fecal bacteria during wet weather events. And that's the line for the wet weather. They don't show the line for dry weather because there's no correlation. So here is a strong correlation. So we have reason to believe that septic tanks work well most of the time, but when it's wet out, we can get a lot of sewage into our nation's rivers and streams. So that concludes the septic system part of our video. And these will be questions that you can answer probably through our quizzes and exam structure. And I've got some videos of the dogs and the dye test and all that already linked into this YouTube playlist. So that concludes everything for the wastewater presentation, and I will stop it there.